Welcome to the Padhai Kar Lo JEE preparation channel. You can practice more problems on this exact topic on our Padhai Kar Lo Android app, link in the description below, or on our website padhaikarlo.com. Today's topic is permutations and combinations, the fundamental tools for counting arrangements and selections. Let's begin. A permutation is an arrangement where order genuinely matters. The number of ways to arrange our objects, chosen from n distinct objects is, NPR equals n factorial, divided by n minus r factorial. A combination is a selection where order genuinely does not matter. The number of ways to choose our objects from n distinct objects is, NCR equals n factorial, divided by r factorial times n minus r factorial. Notice this is exactly NPR divided by r factorial, since each unordered selection or our objects can genuinely be arranged in r factorial different orders. The single most important question to ask before solving any counting problem is genuinely simple: does rearranging the same chosen objects create a genuinely different, distinct outcome? If yes, use permutations. If no, use combinations. The fundamental counting principle underlies everything. If one task can genuinely be done in m ways, and a second, independent, task can be done in n ways, then both tasks together can genuinely be done in m times n ways. This multiplication principle extends directly to any number of successive independent choices. For arrangements with repetition allowed, like forming a password from a fixed alphabet where letters can genuinely repeat, the count is simply n to the power r, dramatically different from arrangements without repetition, which use the standard NPR formula instead. A genuinely classic special case involves circular arrangements. Arranging n distinct objects around a circle gives n minus 1 factorial distinct arrangements rather than n factorial, since rotating the entire circular arrangement produces something that looks genuinely identical, and if the arrangement can also be flipped over like a bracelet, you additionally divide by 2. A genuinely frequently tested trap involves arrangements with identical, indistinguishable objects. The number of distinct arrangements of n objects where some are genuinely identical is n factorial divided by the product of the factorials of each group's repeated count. Exactly the same formula used for arranging the letters of a word like Mississippi. A frequently tested strategy for problems with restrictions, like specific people who must sit together, or specific objects that must never be adjacent, involves genuinely treating the must be together group as one single combined block, first arranging blocks, then separately arranging the members within that block, and multiplying these two counts together. For must never be together restrictions, it's often genuinely faster to count the total arrangements without restriction and then subtract the arrangements where they are together. Also remember the essential complementary counting trick. When a problem asks for at least one of something, it's frequently much faster to calculate the total number of possibilities and subtract the specific cases with known or that particular thing, rather than directly counting every single at least one case separately. Let's recap. Permutations count arrangements where order matters. NPR equals n factorial over n minus r factorial, while combinations count selections where order doesn't matter. NCR equals NPR divided by r factorial. The fundamental counting principle multiplies independent choices and special cases like circular arrangements, identical objects, and together or apart restrictions. Each have their own systematic techniques. When in doubt, ask whether rearranging the chosen objects creates a genuinely different outcome. That's permutations and combinations. Keep the order matters test and the complementary counting trick sharp. They unlock nearly every counting problem in this chapter. If this video helped, please like it and subscribe to Padhai Kar Lo for more JEE preparation content just like this. See you in the next one.